Okay, we are now on question 2 of the sample questions for this section. In this question number 2, diagram a nickel-magnesium system complete with salt bridge, anode, cathode, electrodes, electrolytes. Draw, label, diagram the flow of electrons, give the overall E0 value for the cell, give the half a reaction for each side of the cell in the anode and the cathode, and let me know which electrode is increasing and which is decreasing in mass. Pause this, diagram this, and then unpause and check your answer. Okay, first of all, it's a nickel-magnesium system. So we need to determine the two half reactions from our table. Within our table here, we find our standard reduction potentials of half cells. And for a nickel-magnesium system, I believe that's what it was, yep, nickel-magnesium, we need to find nickel and magnesium. There's magnesium. Magnesium plus 2 electrons, minus 2, and where's nickel in relation to that? Here's nickel. Oops, just lost sight of it. There it is. So nickel, according to this table on the left, the higher it is, the stronger it is as an oxidizing agent. So the top reaction will go in the forward direction here. We have nickel plus 2 electrons going to nickel salt, so that will be our forward, our reduction. As we go down the table, the elements on the right-hand side are the stronger reducing agents. So magnesium, which is, just lost sight of it, here will be our oxidation. So nickel plus 2 electrons goes to nickel solid. Is our first reaction, and our other reaction is magnesium solid goes to magnesium plus 2 electrons. We can get the overall reaction E0 for the cell right away. We just need to determine what are the E0 values for each half reaction for nickel and magnesium. For magnesium, it is minus 1.19. Right here. Oh, that was manganese. Magnesium is actually negative 2.37. Minus 2.37 volts. And for the nickel system, nickel, here it is. It is minus 0.26 right there. Minus 0.26. So the E0 of the overall cell is the E0 of the reduction minus the E0 of the oxidation, which is equal to minus 0.26 minus negative 2.37 plus, which is equal to 2.11 volts. Now I've also drawn, for the purpose of labeling, here will be our overall reaction. Setup with our wire, our salt bridge, and our electrode. Let's start it off making this side the anode, and we'll make sure this side then is the cathode. Using our mnemonic LIOA, loss of electrons is oxidation. our oxidation or losing electrons is the magnesium side, so this electrode will be magnesium. Our half reaction for this side, magnesium solid, goes to magnesium plus 2 electrons. Put that down a little bit. And on this side, the cathode side, our reaction is nickel plus 2 electrons, goes to nickel solid. For our cathode, a suitable metal then would be nickel. Now, if we look at this, this is actually being plated in nickel. Nickel solid is not actually a reactant, which means we could use anything that wouldn't react. An inert electrode would work as well, so we could use platinum, an inert carbon electrode, anything else that would work in particular. However, the electrode on the other side, on the anode side, the solid is being used. It's being used up to create magnesium plus 2, so we are required to have a magnesium electrode on this side. Now for our solutions, our electrolytes, let's start with a salt bridge, suitable non-reacting electrolyte that will also allow ions to move for a current. I like to use ammonium nitrate. Any other non-reacting electrolyte would work as well. Now, you could also use ammonium nitrate as a solution for the magnesium electrode. Since magnesium plus 2 is not a reactant, once again, if it's not a reactant, any electrolyte will do. I tend to like, however, I'll use the same metal that we have, so let's make it a magnesium nitrate solution. But it's not required. It could be ammonium nitrate, as long as it's a suitable electrolyte that would not react itself in the reaction to create a side reaction. However, on the nickel side, we are reacting. Our reactant is nickel plus 2, so we are required to have a nickel plus 2 in this solution. So our electrolyte here should be something like nickel nitrate. So nickel NO3 2. Now, we have our two half reactions here. Which way is the electrons going to be carried in the wire? Well, this reaction is giving off electrons, and this reaction is using it up. So the electrons will travel from anode to cathode. As well, looking at our reactions, nickel is being plated, so this electrode is increasing in mass, and this electrode, as it's being used up, is decreasing in mass. And let's just double check that we've answered the question fully. We've diagrammed and labeled it. We've given the anode and the cathode. We have the salt bridge, the suitable electrodes, flow of electrons, overall E0 value, half reaction for each side, and we've done the increasing, decreasing in mass. So overall, this question is now finished.